I was at a university lab a few months back, watching a researcher monitor a colony of house mice. It was a routine study, until it wasn't. For months, these mice had been living in what looked like a stable utopia. Plenty of food, consistent temperatures, and predictable monogamous pairings. But then, the team decided to turn the screws. They didn't starve them, they just subtly lowered the quality of the grain, making the environment feel slightly more volatile. The shift in the female mice was almost instantaneous. They didn't just get stressed, they became strategically unfaithful. Suddenly, they were seeking out multiple mates within a single cycle. It looked like total behavioral breakdown. One of the undergrads watching the monitors actually laughed and called it a sordid soap opera, assuming the stress had simply made the mice lose their minds. He saw it as a sign of failure, a frantic, irrational reaction to a declining world. But that's where the story takes a sharp turn. When the results came in, those chaotic litters weren't a mess. They were a masterpiece of genetic engineering. Each litter was sired by multiple fathers, creating a wildly diverse pool of offspring. The researchers realized they weren't witnessing a breakdown at all, but the activation of a highly sophisticated, cold-blooded survival algorithm. Those female mice weren't being promiscuous in the human sense. They were running a biological hedge fund. They had sensed the volatility in their world and realized that betting their entire reproductive future on one high-quality male was suddenly a massive risk. If the future was uncertain, they needed a portfolio of different genetic traits to ensure at least someone survived the coming shift. It leaves you with a chilling question. If a mouse's brain can flip a switch and rewrite its entire reproductive strategy the moment the environment fluctuates, what kind of ancient bet-hedging programs are still running silently in the background of our own psyche? And more importantly, what happens when our own world starts signaling that the good times are over?
It is a chilling question, absolutely. But I think if we look at it closely, it's also a deeply illuminating one. Because what you witnessed in that lab wasn't chaos, it was calculation.
Calculation.
And that calculation, that cold, hard math, is the centerpiece of what we're exploring in this deep dive.
Calculation is such an interesting word choice there. Because, usually when we talk about mating or romance or even just family planning, we use words like love or values or commitment.
Right.
We don't talk about algorithms. But today, we are stripping away that layer of modern morality entirely. We aren't talking about right or wrong, loyalty or betrayal in the social sense.
Not at all.
We are talking about biology's desperate mathematical attempt to keep a lineage alive when the walls start closing in.
Precisely. And we have to be rigorous about that separation. I mean, it's critical when we discuss things like debt hedging or sperm competition. We are describing evolutionary mechanisms, not moral imperatives.
Right. These aren't value judgments.
Oh, no. And we've got a fascinating stack of sources to work through today to get to the bottom of this. We're going to be pulling from those specific studies on mouse behavior from the Max Planck Institute that you touched on in the intro.
A brain study, yeah.
The brain study. But we're also layering in papers on evolutionary psychology regarding what they call life history theory and some dense, but I think crucial work on stress recalibration and the HPA axis from the University of Macau, and then some theoretical work on bet hedging by Yukio Yasui.
And we're also going to get into the physiology of human sperm competition, which I should say, fair warning to you listening, it gets very specific.
Of course, it does.
I read the Gallup study on semen displacement, and I honestly don't think I'll ever look at, human anatomy the same way again.
It is certainly a study that changes your perspective. But the core argument we're unpacking is that mating strategies aren't these fixed romantic choices we think they are. They are dynamic.
They're fluid.
They are responsive. They shift based on environmental entropy and volatility.
And that's the key word right there. Volatility. That seems to be the trigger for everything we're going to discuss today.
It is. When the world is stable, the rules of the game are one thing. You can make long-term bets. When the world becomes volatile, the rules change entirely.
And our bodies know that.
Our bodies know that, even if our conscious minds don't.
So let's start with that shift then. The logic of the female strategy.
Yeah.
I want to ground this in a narrative because the math can get abstract really quickly.
Good idea.
I heard a story recently that made me rethink everything I thought I knew about stability. So try to imagine a woman named Laura living in a coastal community where the environment has just suddenly turned chaotic, the tides are unpredictable, the fish stocks are fluctuating wildly.
Okay.
Now, in the past, the right choice was a husband who could build a sturdy, permanent home. Stability. But in this new world, permanence is a trap. I saw a study suggesting that in times like these, the female algorithm for survival shifts toward what biologists call Bet-Hedging.
Right, the core concept.
Yeah. So Alara finds herself instinctively drawn not to one ideal provider, but to a variety of traits across different men. The traveler's immunity, the laborer's raw strength, and the navigator's wit. By seeking genetic diversity across her offspring, she isn't just choosing mates. She's building a diversified biological portfolio. So if a new disease hits, the traveler's child survives. If the terrain shifts, the navigator's child finds the way. And my perspective on this, as I read through the data, was I realized how much we judge reproductive choices through this lens of modern morality, and we often ignore the cold, brilliant logic of survival.
We really do.
To me, Alara's story isn't about a lack of loyalty. It's about a mother's profound subconscious commitment to making sure that no matter how the world breaks, at least one of her children has the tools to fix it. It's the ultimate insurance policy written in DNA.
That narrative of Alara, it effectively captures the essence of bet hedging. But I want to pause on the analogy you used, the portfolio, because in evolutionary biology, this isn't just a metaphor.
It's not just a cute way of saying it.
No, it is a very specific mathematical concept. It's about managing risk.
Okay, let's break down the math. Because usually, when we think of evolution, we think survival of the fittest. Simple. You find the strongest, fastest, smartest mate, and you stick with them. Why would you ever deviate from the best option?
And that logic holds up perfectly. In a stable environment, let's say you live in a world where the weather is always good, the food is always the same type, and the threats are predictable. In that world, natural selection favors optimizing for the mean.
For the average outcome.
The average outcome, exactly. You want to find the one partner who is the absolute best at thriving in that specific environment. It's a specialist strategy.
Right. So if I'm in what you're calling good weather world, I find the guy who has the best genes for good weather. And I double down. I put all my chips on that number because I know the roulette wheel is going to land there every single time.
Exactly. You're 100% in on that one stock. That leads to selecting one partner with the highest perceived genetic or resource quality. You are maximizing efficiency. But now, introduce volatility. Introduce the chaos that Alara is facing.
The game changes.
Completely. In a volatile or unpredictable environment, optimizing for the average is dangerous. In fact, it can be fatal.
Because the average doesn't exist anymore. One day it's a flood, the next day it's a drought. There is no average.
Correct. The mean is a statistical illusion in a chaotic system. So if the environment swings to an extreme, a sudden drought, a new plague, a volcanic winter, and your perfect partner's genes are susceptible to that specific threat, your entire lineage is wiped out.
All your eggs are in that one basket.
All of them. If you have 10 children with that one perfect male and they all share his vulnerability to the new virus, you have 0 survivors. That is a 0 success outcome. Game over.
That's the extinction event. So the strategy has to flip. You stop trying to get the highest score on one specific test, and you start trying to pass as many different tests as possible.
Selection starts favoring optimizing for variance. That's the key term. This is the core of bet hedging. Avoiding the 0 success outcome at all costs.
Okay, so avoiding total failure is more important than achieving total success.
It is the only thing that's important from a gene's perspective. Let's look at the math, but let's keep it simple. Imagine you have 10 coins. In a stable a world where it's always heads, you want 10 coins that are weighted to always land on heads. That's optimizing for the mean. You pick the heads partner.
Okay, so I get 10 winners. I'm rich in genetic currency. My lineage is secure.
It is, for now. But now the environment becomes volatile. You don't know if tomorrow's a heads world or a tails world. If you stick with your heads partner and the world flips to tails, you lose everything.
You're bankrupt.
You have 10 dead coins. 0 success. The lineage ends right there.
It's a dead end.
Exactly.
Okay.
So in a volatile world, you don't want 10 coins that land on heads. You want 5 that land on heads, maybe 3 that land on tails, and maybe 2 that are weird and land on their edge, just in case. You are optimizing for variance.
You're spreading your bets.
You are purposefully choosing what looks like imperfection in the current context to ensure survival in a future, unknown context.
That is a wild way to think about attraction.
Yeah.
That you're not always drawn to the best. You're sometimes drawn to the different. You are purposefully choosing imperfection because you don't know what perfection will look like tomorrow.
You are buying an index fund instead of a single tech stock. Committing to a single mate in a volatile world is like putting 100% of your capital into one stock. It might be a great stock today, but if the market crashes or that sector fails, you are bankrupt.
Whereas polyandry
Mating with multiple males is diversification. You are creating a portfolio of offspring. One might have the immune system to survive the new virus. Another might have the metabolic efficiency to survive the famine. One might be aggressive enough to fight for scraps. Another cooperative enough to build alliances.
That's a toolkit. You're building a genetic toolkit for your descendants.
And this brings us back to those mice in the Max Planck study. I want to unpack the details there because the results were so specific and so elegant in a way.
Yeah, let's get into that, because it wasn't just that they started mating with multiple males. It was when it mattered. Because, correct me if I'm wrong, the researchers found that polyandry happened in both groups, right? The well-fed ones and the poorly fed ones.
Yes, and this is the nuance that makes the science so compelling. They used musculus, the western house mouse, in these large enclosures that mimicked wild habitats. It wasn't a tiny cage.
So it was more realistic.
Much more. And they controlled the diet quality. Not the low-quality, harsh diet. Now, about 1/3 of the litters in both groups had multiple fathers.
So even in the good life group, some of the females were hedging their bets.
They were, which tells you that this behavior is, to some extent, always present. It's a baseline strategy. But, and here is the aha moment of the entire paper, the fitness benefit of that behavior was only seen in the poor quality environment.
Okay, what does that mean, fitness benefit?
It means in the stable, high-quality world, having multiple fathers didn't result in larger, healthier litters. It was statistically neutral. It didn't help. It didn't hurt. It was just a thing that happened.
But in the harsh world, when they were eating the bad grain.
In the harsh world, it was night and day. The mothers who practiced polyandry had significantly larger litters and better offspring survival rates. The variance saved them. The genetic diversity was the key to surviving the stress.
That is fascinating. So when times are good, sleeping around or diversifying doesn't really help you biologically. It's just noise in the system. But when resources are scarce, it becomes an absolute survival necessity.
Exactly. When resources are limited, multiple paternity stops being a choice or a habit and starts being a powerful mechanism to prevent total reproductive failure.
But I have to play devil's advocate here. We're talking about this like it's a free lunch. You know, just mate with more males, get more variance, win the evolutionary game. But reproduction is incredibly expensive, especially for a female mammal.
Oh, massive.
You have gestation, you have lactation. Mating itself takes energy, time, and exposes you to risk. There has to be a cost.
You are absolutely right. There is no free lunch in evolution. This is where parental investment theory comes in, and it's a cornerstone of this whole field. Females are, by definition, the high-investing sex. Eggs are expensive, sperm is cheap. Pregnancy is biologically taxing.
So there has to be a very good reason to take on even more risk.
An overwhelmingly good reason. A female isn't going to spend energy seeking out additional mates and risk disease or predation or retribution from her primary partner unless the math works out. It's a cost-benefit analysis at the deepest biological level.
So the switch only gets flipped when?
The switch to polyandry only flips when the marginal benefit, that insurance policy of genetic diversity, outweighs the marginal cost.
And the marginal cost would be what? Like loss of a provider.
That's a huge one. Loss of exclusive provisioning from a primary mate. If you step out on your primary partner, you risk him leaving. Or you risk him stopping his support, his protection, the food he brings because he's not sure the kids are his. That's a massive risk in a harsh environment.
A catastrophic risk, potentially.
It is. So the female is walking a razor's edge. The standard model of evolutionary psychology usually talks about a trade-off between quantity and quality of offspring. But in volatile environments, the new model suggests the trade-off is between genetic stability, one good mate who helps, and genetic diversity, hedging against the unknown future.
And the female algorithm is constantly running this cost-benefit analysis based on signals from the environment.
Constantly. It's amazing to think of it as an algorithm, but that's what it is. We usually view these things through such an emotional lens, love, lust, betrayal. But underneath, there's this cold calculator just crunching data on food scarcity and social stability and weather patterns.
Which is a terrifying thought.
Yeah.
And it's not just external data like food. It has to be internal data too. How does the body physically sense this volatility? Because unlike the mouse in the cage who can taste that the grain is bad, humans live in complex societies.
Right. It's not as simple as tasting the grain.
Which leads perfectly into our next section. Because we aren't just talking about mice here. We're talking about how humans detect these signals. And this is where it gets a little scary for me, honestly. Because a mouse knows the grain is bad. But how does a human woman's body know that the economy is bad? Or that the social fabric is tearing?
That is the million-dollar question. How do we translate social chaos into a biological signal? And the answer is we have some very old, very sophisticated hardware for exactly that purpose.
I was browsing an old archive of letters from a city experiencing a total socioeconomic collapse. And I won't name the city because I want to focus on the universality of the experience. And I found this narrative that perfectly illustrates how we recalibrate our desires when the world turns to high entropy. A woman named Elena described how, as the banks failed and the social hierarchy just dissolved, the status of the men around her became meaningless. The safe accountant, or the reliable clerk, suddenly seemed invisible to her. They were ghosts.
Their currency was worthless now.
Literally. Her focus shifted to biological signals of resilience. She found herself noticing the men who could heal quickly from a cut, those who remained calm under intense physical stress, and those with just raw vitality. It was as if her internal compass had stopped looking for resource stability, which no longer existed, and started looking for genetic compatibility.
The underlying asset.
The only asset left. In a world where paper money was worthless, the only currency that mattered was the health and adaptability she could pass on to her children. My perspective on this is that it's both fascinating and a bit haunting to realize that our type isn't fixed.
Not at all.
As a journalist, I see this as a reminder that humans are, at our core, incredibly sensitive sensors. When the socioeconomic signals tell us the system is failing, we stop trusting the system and start trusting the biology. We return to the oldest truth there is. In a world of chaos, strength and health are the only real assets.
We stop trusting the system and start trusting the biology. That is a profound way to put it. And biologically, we know exactly how Elena's body, and yours, and mine does this. It's the HPA axis.
The hypothalamic pituitary adrenal axis, the body's stress system.
Correct. This is the hardware that allows for that sensing. The HPA axis coordinates our response to threats and opportunities. For a long time, we thought of stress just as bad. We diagnose it, we treat it, we try to eliminate it. But in evolutionary terms, stress is information.
It's data.
It's pure data about the state of the world.
So high stress tells the body the world is dangerous right now, but does it just tell us to run away? Or does it actually change how we develop, how we're built?
To understand this, we have to look at the adaptive calibration model, or ACM. And I want to slow down here because this is really the engine room of the whole theory.
Okay, so if the brain is the CEO, the ACM is what? The risk management department.
That's a great analogy. Think of the HPA axis as a thermostat, but instead of measuring temperature, it's measuring risk. In a safe childhood, that thermostat is calibrated to low sensitivity. It takes a lot to set it off.
Because the data coming in says food is plentiful, my caregivers are around, there are no predators in the cave.
Precisely. The system learns that the world is generally safe and predictable. But here is the nuance the Macau paper highlights. If the data from childhood says the world is on fire, the HPA axis doesn't just break, it doesn't become dysfunctional, it optimizes.
Optimizes for chaos.
It becomes highly sensitized. It sets the body to a hair trigger alert status. It calibrates for a high-risk world.
Which, in the modern world, we usually diagnose as an anxiety disorder. We call that a bug, not a feature.
We call it generalized anxiety disorder, or PTSD, yes. But in the ancestral world, that wasn't anxiety, that was readiness. And this drives what we call a fast life history strategy. If your internal risk management team tells you the market is about to crash, meaning you might die young, what do you do with your biological capital?
You spend it now. You don't put it in a 401k, you cash out immediately.
Exactly. You mature faster. You hit puberty earlier. You reproduce now because later might not exist. This is why we see earlier in menarche, the first period in girls growing up in unstable homes. It's not just stress slowing them down, it's the body accelerating the timeline to beat the clock.
Versus a slow life history strategy.
Right. That's the other side of the coin. If the world is benign and stable, your biology says, take your time, invest in your own growth, delay reproduction, invest heavily in a few offspring, plan for the future. That's the slow strategy, the 401k plan.
But here is where it gets really interesting. And this was in the paper from the University of Macau. We used to think this calibration was set in stone during childhood. Like, once your thermostat is set, that's it for life. If you had a rough childhood, you're a fast strategist forever. But that's not true, is it?
No, and this is a game changer for understanding human flexibility. There's a theory of recalibration. The research suggests that the stress response system isn't fixed forever. Specifically, pregnancy, the perinatal period, acts as a developmental switch point.
A switch point. Like a junction in a railway track.
A perfect analogy. A woman gets pregnant, and her body basically opens a developmental window again and says, okay, let's recheck the weather out there before we finalize the programming for this new individual.
It's a final check on the data.
Precisely. It is a window of heightened neural plasticity. During pregnancy, the mother's body reassesses the environment to program the fetus, and crucially, to adjust her own strategy for the world as it is now. If her environment has shifted, say she grew up in a stable home, but now she's living through that socioeconomic collapse Elena described, her biology can recalibrate to match the current conditions.
That is wild. So she might have been calibrated as a slow life history person her whole life, but the experience of pregnancy in a chaotic world can flip her, or at least push her toward a fast strategy.
It can shift the dial, and it makes perfect sense evolutionarily. Why rely on data from 20 years ago, your childhood, when you have fresh, real-time data right now about the world your child is about to be born into?
It's like a software update.
It is a critical...
And the fetus is involved in this too, right? I read that it's not just the mother deciding everything.
No, the fetus is an active participant. We sometimes call it maternal-fetal conflict and cooperation. The fetus is receiving signals via placental, CRH, corticotropin-releasing hormone, and other hormonal markers. The fetus is basically getting a weather report directly from the mother's blood.
So the fetus is tasting the mother's cortisol levels, stress hormones.
Yes. And there's this concept of the second hit. If a woman experienced early life stress, that's hit number 1, and then she experiences significant stress during pregnancy, that's hit number 2. The interaction can radically alter her physiology and behavior and the baby's. It's like the body confirms the data. Yes, the world was dangerous then, and it is still dangerous now. We need to adapt immediately and prepare for the worst.
Wait, we need to distinguish between two terms the researchers use because they sound the same, but they do different things to the brain: harshness and unpredictability.
Ah, yes, a critical distinction. And it matters hugely for parenting. Harshness refers to high morbidity or mortality rates, just raw danger. A war zone is harsh. A very cold winter with little food is harsh.
But you can predict winter. You know it's coming every year.
Exactly. That's harsh but predictable. Unpredictability is the variance in those rates. It's chaos. It's not knowing if you will have food tomorrow. It's not knowing if the rules of your society will change overnight. It's the feeling of being on unstable ground.
And how do those two different things affect the child's development?
Generally, both harsh and unpredictable environments tend to push offspring toward those fast LH traits we talked about: aggression, impulsivity, early sexual debut, the live fast, die young approach. However, and this is the hopeful part of the data, the part that keeps me from getting too cynical, parental investment acts as a buffer.
This was the part that gave me some relief when I was reading this, because hearing about all this biological programming can make you feel a bit helpless, like it's all destiny. But the study says that even if the world is burning down outside, if the parents are responsive inside the home, it changes the outcome.
It does. It can change everything. High responsiveness from parents, being attentive, consistent, loving, can decelerate the child's life history strategy. It effectively shields the child from the signal of chaos coming from the outside world. The parent becomes the environment for the child.
So even if the socioeconomic signals are flashing red, the direct parental signal can be green. And the green light is the one the child's biology listens to.
Precisely. The parent acts as a filter. If the child feels safe with you, their HPA axis doesn't need to calibrate to the fast strategy, even if you are living in a tent. That attachment is a powerful biological signal of safety.
That is incredibly empowering. It means biology isn't destiny. It's a constant negotiation between our genes and our environment. But speaking of negotiations, we have to talk about the other side of this biological coin.
The counter move.
Exactly. So far, we've focused heavily on the female strategy, the bet-hedging, the recalibration. But if females are running the sophisticated algorithms, shuffling their genetic portfolio, what are the males doing? Because they aren't just sitting there watching it happen.
No, they are certainly not. In evolutionary biology, for every strategy, there is a counter strategy. It's an arms race.
I want to introduce this perspective with another story. And I'll be honest, this one feels a bit darker, a bit more raw. I want you to try to imagine the perspective of a man named Kale in an ancestral environment characterized by extreme scarcity and constant migration.
Okay, a tough world.
A very tough world. Kale lives in a world where the social contract of exclusivity is constantly being undermined by the sheer volatility of life. He is part of a biological arms race that he isn't even consciously aware of. Because the women in his tribe were subconsciously hedging their bets to ensure offspring survival, Kale's body has adapted with what scientists call sperm competition.
The invisible war.
A silent, invisible war. His biology is tuned to produce more, faster, and more competitive soldiers to ensure his lineage isn't erased by the diversity strategy of his partners. He feels this deep-seated instinctual pressure to compete, not just with his fists or his hunting skills, but at a microscopic level, because the environment is too unstable for any one man to be a sure thing. And my perspective on this story is that it can feel a bit raw or even aggressive. But when I look at it through the lens of evolutionary biology, it feels more like a tragedy of persistence. It shows that the male response to volatility isn't just about ego. It's a biological manifestation of the drive to exist. Even when the world is stacked against us, every cell in our bodies is screaming to find a way forward. It's a testament to the incredible, sometimes desperate energy it takes for life to continue across generations.
A tragedy of persistence. That is a very poetic way to describe what is biologically a ruthless numbers game. Kale's situation describes sperm competition.
Which, to be clear for everyone listening, isn't about men fighting in a stadium.
Chuckles, no. It is a form of post-copulatory sexual selection. It happens after mating. It's when the sperm from rival males compete to fertilize a single ovum inside the female reproductive tract. And it only occurs in species where females mate with multiple males within a fertile window, which, as we've established with the mice and with Alara, becomes more common in volatile environments.
So if the female is bet-hedging, the male's biology has to respond. If it doesn't, his lineage just ends. And we can see the evidence for this in human anatomy, right? I was struck by the comparison to other primates in the sources.
It's one of the clearest physiological indicators of our evolutionary history. If you look at testis size relative to body weight across primates, it tells a very clear story. Look at the gorilla. Massive animal, the silverback king. He fights other males to control a harem. Once he wins, he has exclusive access. No other sperm is getting in there.
So he doesn't need to compete on the inside in the reproductive tract. He's already won the battle outside.
Exactly. He's a gatekeeper. So gorillas have tiny testicles relative to their massive body size. They don't need the volume. They don't need to produce a lot of sperm. Now look at the other extreme, the chimpanzee.
Right.
They live in multi-male, multi-female groups. It's a free-for-all. Females mate with lots of males. The sperm competition is incredibly intense. It's a mad dash to the egg every single time.
So they need volume. They need an army.
Massive volume. Chimps have huge testicles for their body size.
Okay, so you have tiny on one end with the gorilla, huge on the other with the chimp. And humans, where do we fall on that spectrum?
We are right in the middle. We have intermediate testes size. And this strongly suggests our evolutionary history isn't purely monogamous like the gorilla, nor is it purely promiscuous like the chimp. We have a history of moderate sperm competition. Our biology is designed for a world where fidelity is the general rule, but bet hedging is a recurring reality.
The sources also mentioned the sperm mid-piece. I'm less familiar with that. That's the engine.
Right. Yes, that's where the mitochondria are packed. It powers the tail for swimming. And human mid-piece size is also consistent with that intermediate level of competition. We are built for a race, but not a sprint against 50 other guys every single day.
But where it gets really fascinating, and frankly a little disturbing, is the concept of ejaculate adjustment. This is the sperm count phenomenon.
Right. This is where the body adapts in real time. Multiple studies have shown that men produce more sperm and more motile active sperm after spending time apart from their partner.
So let's make this concrete. If a man goes away on a business trip for a week, when he returns, his sperm count is higher.
Significantly higher. And importantly, it goes up relative to the amount of time they were separated. The evolutionary logic is that separation increases the risk, however small, that she might have mated with someone else.
Even if he trusts her consciously. Even if he knows, logically, that nothing happened.
Yes, that's the key. This is not conscious. He might trust her implicitly. But his testicles don't. His body unconsciously responds to this abstract cuckoldry risk by, to put it bluntly, loading the gun. It increases the number of troops to outnumber any potential rivals that might already be in the reproductive tract.
Now, I have to ask you about the kamikaze sperm thing, because I remember reading about this years ago, this idea that some sperm aren't for fertilizing, but are actually killer sperm designed to attack and block rival sperm, like little soldiers with spears. It sounded like a movie plot.
Yes, the Baker hypothesis. It's a very dramatic idea, very cinematic. It definitely captures the imagination. But I am going to have to burst that bubble.
So it's not real.
Current research, particularly by people like Moore and Burkhead, has largely debunked it. When you mix sperm from different men in a laboratory setting, they don't attack each other, they don't form little armies or blockades, there is no warring sperm.
So it's not hand-to-hand combat down there.
No, it's a lottery. The real adaptation is what scientists call prudent sperm allocation. It's about volume and quality. If you buy more tickets, you're more likely to win the lottery. That's the strategy. It's an economic strategy, not a military one.
Okay, but then we get to the Gallup study. And this is the part that sounds like something out of science fiction. Or maybe bad erotica, the actual shape of the human penis.
This is the displacement theory. It's definitely one of the more provocative ideas in the field. Gordon Gallup and his team at SUNY Albany proposed that the human penis, specifically the shape of the glands and the coronal ridge, functions as a semen displacement device.
A squeegee. You're saying the penis is a biological squeegee.
Essentially, yes. The theory is that the ridge at the base of the head acts to pull rival semen that might already be present out of the reproductive tract before the male deposits his own.
That seems overly mechanical. I have to stop you there, because this is painting a pretty grim picture. We're talking about intimacy, what is for many people the most private act between two people, and you're describing it like it's a tactical cleaning operation. Doesn't this view just strip away all the human element? Does the data really support that men are unconsciously using their anatomy as a tool, or are we just overlaying a clever theory onto biology?
It's a completely fair pushback, and honestly, when Gordon Gallup first published this research at SUNY Albany, people were outraged. They called it crude biological reductionism. It feels cold, it feels dehumanizing, but here is where the data gets stubborn.
Okay, hit me with the data.
It's not just the shape, it's the behavioral correlate. If this was just a random quirk of anatomy, we wouldn't see a specific change in behavior that matches the theory. The study found that after allegations of infidelity, or even just after long periods of separation, which increase that cuckoldry risk, men report engaging in different sexual behaviors, specifically deeper, quicker thrusting.
Wait, don't tell me.
Yeah.
That maximizes the displacement effect.
Exactly. The physics of the squeegee effect, as modeled, requires about 75% depth insertion to work effectively. So this instinctual drive to thrust deeper and more vigorously after a separation isn't just passion or missing each other. It tracks perfectly with a biological maneuver to clear the field of potential competitors.
That is brutally functional. It really does strip the romance right out of it. But I guess that's the theme of today's deep dive.
But it helps explain the psychology. It bridges that gap between the physical and the emotional. We talk about mate-guarding behaviors.
You mean jealousy?
Yes. Jealousy is often pathologized in modern therapy, but from an evolutionary perspective, it's a retention strategy. It's an adaptive emotion designed to prevent cuckoldry and ensure paternity.
And the sources mentioned Yasui's research on mites here, which I thought was a weird connection at first, but it actually makes a lot of sense.
Yasui's work is fascinating. He showed there's a trade-off. In his mites, you can either guard your mate, physically prevent them from interacting with other males, or you can compete via sperm competition. You can invest your energy in one or the other. Humans seem to do both. We have the psychological jealousy, the mate guarding, and we have the physiological response, the sperm competition.
It's an arms race where both sides are constantly adapting. The female algorithm seeks diversity to survive volatility. The male algorithm seeks exclusivity to ensure paternity. And they are locked in this dance.
A dance that has been going on for millions of years. And the music for that dance is the environment. When the music changes, when the environment gets volatile, the dance steps change dramatically.
So let's unpack this. What does it all mean for us today? We've looked at the mice, the HPA axis, the sperm wars. When we zoom out, what is the big picture we're looking at?
We are looking at the environment of evolutionary adaptedness, or the EEA, operating in real time. We tend to think of evolution as something that happened back then to people in loincloths. But these programs are running on our modern hardware now.
It's a chain reaction then.
It is. Environmental volatility triggers the female bet-hedging, the subconscious drive for polyandry and genetic diversity. That, in turn, triggers the male counter-strategy sperm competition and psychological mate guarding. It's a cascade.
I think it's crucial to reiterate what we said at the start. These aren't conscious thoughts. A woman in an unstable economy isn't sitting there with a spreadsheet thinking, I need more genetic variance for my offspring.
No, she's thinking, I'm so stressed, or I don't feel attracted to my partner right now for some reason, or that stranger I just met looks incredibly compelling and I don't know why.
The algorithm manifests as feeling. It manifests as desire or lack thereof.
The sources mention some modern vestiges of this, like the finding about earlier monarch in unstable homes. Yes, that's a classic example. Girls growing up in homes without a father figure or with high levels of conflict tend to hit puberty earlier. Their bodies are reading the signal from their immediate environment. The world is unstable, don't wait, reproduce now. It's the exact same logic as those mice eating the low-quality grain.
And the attraction to resilient traits during economic downturns.
Exactly. When the stock market crashes, the safe, reliable, nice guy with a steady office job might suddenly lose his appeal compared to the guy who looks like he could survive a disaster. We unconsciously shift our valuation from provisioning to good genes.
It really forces us to reframe how we talk about cheating or promiscuity.
It does. We judge these things morally, and for good social reasons, trust is the glue of society, after all. But biologically, the behavior described in the mouse study and hinted at in all this human anthropological data isn't about malice. It's not about being a bad person. It is a desperate mathematical attempt by the genome to avoid extinction.
So in a world of chaos, the ultimate stability isn't a single partner. It's the resilience that comes from a diversified lineage.
Precisely. The bet-hedging program is the biological acknowledgement that the future is never, ever guaranteed. It's a humble admission by our genes that they don't know what's coming next, so they better be ready for absolutely anything.
That is a powerful thought to end on. We like to think we are the masters of our destiny, making rational choices based on love and logic. But running silently in the background, there's this ancient code, constantly checking the weather, checking the stock market, and whispering to us that if the storm is coming, we shouldn't put all our eggs in one basket. It leaves you with this realization. The next time you feel a sudden, inexplicable shift in what or who you want, it might not be your heart speaking. It might be the algorithm, quietly preparing for a crash.
And if it is, that suggests your biology knows something about the world that your conscious mind has yet to figure out.
Thanks for diving deep with us.
Always a pleasure.